Question 1a. Solve 5x equals 15. So it's a 1 mark question. This is a one-step equation. I know that 5x is the same as 5 multiplied by x. So I'm going to do the inverse. I'm going to divide by 5. So x equals 15 divided by 5, which is 3. I'm going to pop 3 on the answer line there. 1b. Solve y add 7 equals 50. So again, a one-step equation. This time the inverse I'm going to do is I'm going to subtract 7 because I want to eliminate this plus 7. So y equals 50, subtract 7, which is 43. So y equals 43. 1c, solve c divided by 4 equals 8. It's a fraction, so it's a division. The opposite of dividing by 4 would be to multiply by 4. So c is equal to 8 multiplied by 4, which is 32. Question 2. Here is a list of numbers. So we have 10, 8, 2, 11, 12, 15, 4 and 4. Write down the mode. The mode is the most common, and the most common number in that list is 4. It appears twice where all the other numbers appear once. So the mode is 4. 2b, work out the median. Median is the middle of the data set. So I need to write these numbers in order. So 2, 4, 4, 2, 4, 4. Then it would be 8, 10, 11, 12 and 15. So now I'm going to cross off one from either side until I find the middle number. So we're left with 2 numbers in the middle here. So I need to find halfway between 8 and 10. I know that halfway between 8 and 10 is 9. If you weren't sure, you could add them together and then divide the answer by 2. So 9 is the median. 2c, work out the range. So the range is the biggest, subtract the smallest. So the biggest number in that list, I'm going to look at my ordered list because it makes life a little bit easier, is 15. The smallest number is 2. 15 subtract 2 is 13. So my range is 13. 3a. A fair spinner with 5 sections is spun. Complete these statements. The spinner is most likely to land on section, that would be section D, because D is the largest section of the spinner. The spinner is equally likely to land on sections A and E because they are sections of the same size. 3b. 2 different spinners are spun. One spinner has sections labelled with colours, the other spinner has sections labelled with numbers. Here is a list of all the possible outcomes. So this is all the possible outcomes from spinning both spinners. Show the possible sections on the 2 spinners. Okay, so the coloured options for this spinner are red, blue and green. So we could just split that into 3 sections. It doesn't matter about the size because we haven't been given the probability, but we need to make sure that there's a possibility of landing on red, a possibility of landing on blue, and a possibility of landing on green. Now we need to do the number spinner. So the number options for that spinner are 1, 2, 3 and 4. So again, it doesn't matter how we split this, but we need an option for 1, 2, 3 and 4. Question 4. A reel holds 9.5 metres of ribbon. 2 pieces of ribbon are cut from the reel. Each piece is 20 centimetres long. What length of ribbon is left? Okay, so if we're cutting 2 pieces of ribbon that are 20 centimetres long, those 2 pieces are 40 centimetres in total. So we need to subtract 40 centimetres from 9.5 metres, but it will be easier to do that if they're both in the same units. So 9.5 times by 100, because there are 100 centimetres in a metre, tells us that there are 950 centimetres on the reel in total. So we're going to subtract 40 from 950. So 950 subtract 40 is 910 centimetres. So that's how much of the ribbon is left on the reel. Now it says state the units of your answer, and there's no units on the answer line. So I can give them my answer in centimetres, or I can give them my answer in metres. It doesn't matter which. But because I worked it out in centimetres, I would probably just leave it in centimetres because it doesn't tell me to do anything different. (5A). The term-to-term rule for a sequence is subtract 1, then multiply by 5. The first term is 4, work out the third term. So the first term is 4, the second term will be 4, subtract 1, and then multiply by 5. So 4 subtract 1 is 3, still need to multiply it by 5, so the second term is 15. We want the third term, so we're going to now use 15. So we're going to do 15 subtract 1 and then multiply it by 5. Well, 15 subtract 1 is 14, and then 14 times 5, don't forget you've got a calculator for this paper, is 70. So the third term is 70. 5B. The term-to-term rule for a difference sequence is add 20, then divide by 2. The second term is 50, work out the first term, okay? So to get the second term, we would have done the first term, add 20, and then divide by 2. But we're given the second term, so we're going to do the opposite. So instead of adding 20 and then dividing by 2, we're going to multiply by 2 and then subtract 20. So we're starting with 50. So 50 multiplied by 2 is 100. Subtract 20 is 80. So the first term would have been 80, and you can check that. 80 add 20 is 100, divided by 2 would give us 50. Question 6. Scarlett leaves home at 10 o'clock in the morning to cycle to the supermarket. Here is a part of a distance time graph of her trip to the supermarket. So, started at 10 o'clock, travelled to the supermarket, stayed in the supermarket for a little amount of time, and then that's where the graph stops, because that horizontal line there means we're stationary, we've stopped. 6A, she arrives at the supermarket at 10:20, which is this point here. How far is a supermarket from her home? So this is the distance on the left-hand side. So we're going to read across here to that point there. So we've got 2 larger squares per 2 on the scale. So that must be 1, 3, 5, 7, 9. So the distance is 7 kilometres from her home. Okay, she leaves the supermarket at 10:35. Well, they've popped that there on the graph. That's where she stayed at the supermarket until. How long does she stay at the supermarket? So we need to look at this horizontal line where she was at the supermarket and staying there. If we read down here, from 10:20 to 10:35. So we're going from 10:20 to 10:35. That's a difference of 15 minutes. So she was in the supermarket for 15 minutes. Question 7. This week, Liam works 25 hours at £10.20 per hour and extra hours at the weekend at £11.80 per hour. Here are the extra hours he worked at the weekend. So he worked Saturday from 7 a.m. to 10 a.m. So that's 3 hours. And then Sunday 1 p.m. to 3 p.m. So that's 2 hours. In total, how much has he paid this week? So first of all, it's worked 25 hours at £10.20. So let's work out what that is. So 25 times £10.20 is £255. Now we need to work out how much he's paid for these extra hours. Well, there was 3 hours on Saturday, 2 hours on Sunday, so that's 5 hours in total. So we're going to do 5 times the extra hour hourly rate. So 5 times £11.80, which is £59. And then we're going to add those two together. So 59 is already on my calculator, plus the 255 is a total of £314. So pop that on our answer line. Question 8. 3 oranges have masses of 60 grams, 70 grams and 85 grams. Show that their total mass is between 1/5 and 1/4 of a kilogram. Okay, so if we're looking at comparing their total mass, let's find out what their total mass is. So 60 plus 70 plus 85. 60 plus 70 plus 85 is a total mass of 215 grams. So we want to show that it's between 1/5 and 1/4 of a kilogram. So 1 kilogram is equivalent to 1,000 grams. So if we find a fifth, so 1/5 of 1,000, so 1,000 divided by 5 is 200 grams. And then 1/4 of 1,000, so 1,000 divided by 4 is 250 grams. So we can say that 1/5 is 200 grams, which is less than the 215, but 215 grams is less than the 250. So we've shown that that value is somewhere between 1/5 and 1/4. Question 9. For each statement, tick the correct box. So we've got boxes for always true, sometimes true, and never true. So first statement, one of the 3 angles of a triangle is 90 degrees. Now we can have a triangle that has a 90-degree angle, and it's a right angle triangle. But there are more triangle types than right angle triangles. We can have scalene triangles where none of the angles are the same. We can have isosceles triangles, equilateral, etc. But there's only one option for a triangle that we can have a 90-degree angle in. So it's not always true because we've got those different types of triangles. It's not never true, so this one's sometimes true. So sometimes one of the 3 angles of a triangle is 90 degrees. Next statement, one of the 3 angles of a triangle is obtuse. Now the definition of an obtuse angle is greater than 90 degrees, but less than 180 degrees. If we have an angle greater than 90 degrees, we could potentially have extremely small acute angles, but we couldn't have more than one obtuse angle in a triangle. And there'd be very few cases where that occurs. So it can't always be true, but it could sometimes be true. And the final statement, one of the 3 angles of a triangle is a reflex angle. Now the definition of a reflex angle is that it's greater than 180 degrees. Angles in a triangle add to 180 degrees, so it is not possible that one of the 3 angles of a triangle could be reflex. So that's never true. Question 10a. Simplify fully p squared times by p. So what we need to remember is that this p has that invisible power of a 1, and the laws of indices for multiplication say that if they have the same base, which they do, p is the base, then we can simply add the powers to simplify. So we're going to have p to the power of 2 add 1, which is p to the power of 3, or p cubed. 10b. Simplify fully. 3a plus 5c subtract a plus 6c. So we're going to collect like terms. So first of all, I'm going to deal with the terms that have an A in them. So 3A subtract A. It's important that we use the sign in front. So 3A subtract A is 2A, and then positive 5C plus 6C is 11C. So 2A plus 11C, because that 11C was a positive answer. Question 11. Two angles around a point are shown. So we've got these two angles here, this angle and this angle, both around that point. The angles are in the ratio 2 to 7. Show that the larger angle is 280 degrees. Now, angles around a point sum to 360 degrees because it's a full circle. So that 360 degrees, we're going to share it into this ratio 2 to 7. So 2 plus 7 means we have 9 parts of the ratio in total. So we're going to divide the sum of the angles, 360, by 9. Remember, it's a calculator paper. 360 divided by 9 is 40. So each part of the ratio is worth 40. The smaller angle and the larger angle. So the smaller angle is 2 times 40, which is 80. And the larger angle is 7 times 40, which is 280. It wants us to show that the larger angle is 280. Just label it in some way to identify which one you believe is the larger angle, and then we're done. 12A. We have C is greater than 4, D is less than 4, and C subtract D is equal to 6. Work out a possible pair of values for C and D. So we want a value for C that's greater than 4 and a value for D that's less than 4, that when we subtract the value of D from the value of C, we get an answer of 6. So possible options for C then could be, it's got to be greater than 4, so we could have 5, 6, 7, 8, 9, etc. For D, less than 4, so we could have 3, 2, 1, 0, minus 1, etc. So we want to take a value of C that when we subtract the value of D, we get a difference of 6. So here we could go 7 subtract 1. If C equals 7 and D equals 1, C subtract D becomes 7 subtract 1, which is 6. So let's go with those. You could also have had 8 and 2 because they've got a difference of 6, 9 and 3, but that was the first one that I spotted. 12B, W is greater than 1 and less than 2. X is greater than 0 and less than 1. And W plus X is equal to 2.6. Work out a possible pair of values for W and X. Okay, so what I'm going to do is I'm going to start with a value of W that is greater than 1 and less than 2. So let's go with W equals 1.9. So if W equals 1.9, which is greater than 1 and less than 2, then I'm going to pop that value in there. So 1.9 substitute for W plus X equals 2.6. So X is equal to 2.6 subtract 1.9. Now what I want is this answer to be less than 1 but greater than 0. Okay, so the answer is 0.7, which is greater than 0 and less than 1. If it wasn't, then I would go back and try another value of W between 1 and 2 until I found a value that fell between 0 and 1 for X. So we're going to say that W can be 1.9 and X can be 0.7. Question 13. Here are 3 straight lines. So we've got AB, CD, and then we've got that line, that intersecting line there. Are the lines AB and CD parallel? So we want to know if these two lines are parallel. So to figure this out, we need to know some of the other angles because there are some rules that can tell us that lines are parallel. So corresponding angles need to be equal, alternate angles need to be equal, co-interior angles need to sum to 180 degrees. So if we fill in as many angles as we can see if one of those rules applies. So the first angle I'm going to complete is this one. Vertically opposite angles are equal, so this angle must be 105. If this angle is 105, then I can find this one by subtracting 105 from 180 because they're on a straight line. So 180 subtract 105 is 75. Okay, I can also find this angle using the same rule. These two angles are joined on a straight line, so they must add to 180. So 180 subtract 95 is 85. Now I'm going to stop there because I've got two angles that I can compare. So you might have been told to look for an F shape. So these are corresponding angles. So if A, B and C, D were parallel, this angle and this angle would be the same. They're not the same. So we're going to say no, they're not parallel, and working to support your answer, well, you've popped up the angles there, but you could be safe and mention there are no corresponding angles, and that's a condition for two lines being parallel. Question 14. Match the algebra to the correct description. One has been done for you. So these are the algebra statements and here are the descriptions. So 5D add 7E has been matched to an expression. So this is an expression, not an equation, okay? An equation would have an equal sign, which will make life a little bit easier for us when matching the equation word up, because it means it's going to go not here, because that's not an equal sign, that's an identical to sign. This one is an equal sign, so that is an equation, so let's match that up straight away. Now we just mentioned that 3 lines here, so 2 lines is equal to, 3 lines is identical to. If you have those 3 lines, it means it's an identity. And what that's saying is 2C plus C is the same as 3C. Well, it is, because 2C plus 1C is 3C. So we're going to match that to the identity. Now it's the last one. Is it a formula or an inequality? Well, we're using a greater than symbol. If we use any of the less than, greater than, less than or equal to, greater than or equal to symbols, it is an inequality. So we didn't need to use the formula box for this question. Question 15. Popcorn is sold in bags. 8 small bags have a total mass of 496 grams. 5 small bags and 2 large bags have a total mass of 638 grams. Work out the mass of a large bag. Okay, so I've been given some information about small bags. So I'm going to use a proportion table, which I've used before in previous videos. So this is mass and then number of bags. So 8 bags have a mass of 496 grams. If I want to find out what one small bag weighs, I'm going to divide by 8, and then I can do the same on the other side. So 496 divided by 8 is 62 grams. So one small bag weighs 62 grams. So we're told that 5 small bags and 2 large bags have a total mass of 638 grams. So now I want to know how much 5 small bags weighs. So now I know what one small bag weighs. If I multiply that 5, it will tell me what 5 small bags weigh. So the weight of one bag, 62, multiplied by 5. So 5 small bags weigh 310 grams. So 5 small bags, 310 grams, plus 2 large bags must equal 638 grams. So if I take away the 310 grams for the small bags from 638, it'll tell me what 2 large bags weigh. So 638 subtract 310. It's 328 grams. So that's the price of the weight of 2 large, sorry. So again, bags, mass. This is for the large ones. So 2 bags is 328 grams. So if I want one bag, I'm simply going to divide by 2. and half that. So 328 divided by 2 tells me that one bag weighs 164 grams, and that's our answer. Question 16. The rectangle and the triangle have the same area. So we've got a triangle, and to work out the area of the triangle, it would be base times height and then divide by 2. And then we've got a rectangle, and to work out the area of the rectangle, it would be the length times the width. But here we don't know the length. It wants us to work out the length of the rectangle. So if they have the same area, the first thing I'm going to do is I'm going to find the area of the triangle. Because I have the base and height, I can do that. So it's the base of 12 multiplied by the height, which is 16, and then divide by 2. So 12 times 16 divided by 2 is 96 centimetres squared. So the area of the triangle is 96 centimetres squared. The rectangle and the triangle have the same area. So now if I divide that area by the width of the rectangle, it will tell me what the length of the rectangle is. So 96 divided by 7.5 is 12.8. So the length of the rectangle is 12.8 centimetres. Question 17. Match the name to the correct sequence. One has been done for you. So a quadratic sequence has been matched up to this sequence here. So this must be a quadratic sequence. We now need to find a linear sequence and a Fibonacci type sequence. So a linear sequence is one where it goes up or down by the same value between each term. So we're either adding the same value to get the next term, or we're subtracting the same value. So let's try and find that one first. So 4 to 5 is 1, 5 to 9 is 4. Straight away these are different, so that can't be my linear sequence. Let's try this next one. Minus 3 to 1, we would add 4. 1 to 5, add 4. 5 to 9, add 4. 9 to 13, add 4. 4 every time. That's a linear sequence. Now we need to identify the Fibonacci type sequence. So a Fibonacci sequence is a sequence that's generated by adding the previous two terms. So if the first two terms were 1, the third term would be 1 plus 1, which is 2. The fourth term would be 1 plus 2, which is 3. The fifth term would be 2 plus 3, which is 5. So let's see if we can find that property in a sequence anywhere. So let's continue this one. From 4 to 5, 4 plus 5 is 9. That works. 5 plus 9 is 14. That works. 9 plus 14 is 23. That works. So this is our Fibonacci sequence because we're adding the previous two terms to make the next one. Question 18. The number of hedgehogs in England is expected to reduce by 4% each year. So that reduce by 4% is important. Assume there are now 1 million hedgehogs in England. Work out the expected number of hedgehogs in England after 5 years. You must show your working out. Okay, so if we're reducing by 4% each year, 100% subtract 4 would be 96%. 96% as a multiplier is 0.96. So this is what we're going to use in our calculation to reduce by 4% each year. Now it wants the expected number of hedgehogs after 5 years. So we're going to use a formula that you may have seen as a compound interest formula, but it could also be used for depreciation problems. So when they're being reduced, a repeated reduction over a period of time. So we're going to take that starting number of hedgehogs, 1 million. We're going to multiply it by our multiplier for that 4% reduction, and then we're going to raise it to the power of 5 years. And then we're going to pop that in our calculator. So 1 million times 0.96 to the power of 5. So that tells us, gives us an answer of 815,372.6976. We can't have 0.6976 of a hedgehog, So we're going to write our answer as 815,372. Question 19. Here is a cuboid A. Cuboid B is made from 2 of cuboid A, so they've been popped on top of each other. The volume of A to the volume of B is in the ratio 1 to 2. Matthew says the surface area of A to the surface area of B must be 1 to 2 because B is made of 2 of A. Is Matthew correct? Now what we need to remember is the surface area is all the way around the outside of the shape. So it's the area of all of the faces on the outside of the shape added together. So imagine you're wrapping a present. It's the amount of wrapping paper you're going to need to get all the way around that present. Now, when we're looking at cuboid B, yes, it is 2 of cube A. However, this bottom face of A is hidden here. And what would be the top face of that second cube is also hidden. So the ratio can't be 1 to 2 because 2 of the faces are hidden. So 2 of the faces from this cube and the other one added to it are not included in that surface area anymore. So I'm going to say no. And I'm simply going to say 2 faces are hidden on cuboid B that would have been included in the surface area if they were 2 separate cuboid A's. You can put some numbers to it if you want to. So if each of these sides had an area of 1, that would be a surface area of 6. And then this would be a surface area of 10. So it would be a ratio of 6 to 10, which would simplify to 3 to 5. But really, you just need to explain your reasoning for it. And the reasoning is that there are faces hidden that aren't going to get counted in the surface area, so it can't be a direct 1 to 2 ratio. Question 20a. Complete the table of values for y equals x squared plus 2x. So these are our x values. These are the y values that get generated when we substitute x into this quadratic equation. So it's a calculator paper. What's going to be best in our calculator is when we're adding in this x value to substitute, we're going to add it in brackets like this. So it's the x value squared, x squared plus 2 times the x value. So here the x value is minus 2. So that's what I'm going to type into my calculator. So bracket -2 squared plus 2 times -2. So I'm going to pop my answer there. That gives me an answer of 0. Now what I'm going to do, rather than write that all out again, to substitute the value 1 in, I'm just going to arrow back, and wherever I put that -2, I'm going to put the 1. That's why the brackets help, because you can then replace it, which gives us a value of 3. So that's part A done. Part B. Draw the graph of y equals x squared plus 2x for the values of x from -3 to 1. So this is the same quadratic equation that we've just generated the values for, and the values of x from -3 to 1, well, we've done that as well, -3 to 1. So now we're going to use these as pairs of coordinates. So to plot this point, we're going to go along the x-axis to -3, then we're going to go up the y-axis to 3. To plot this point, we're going to go along the x-axis to -2, and then we're going to be at 0 because y is 0. Along the x-axis to -1, and then to -1 on the y-axis. Along the x-axis to 0, we're at 0 again. And then along the x-axis to 1, and then to 3 on the y. We'd expect to see a little bit of a curve because of the x squared, and it's a positive x squared, so we'd expect that curve to be a U shape, and then it's simply a case of drawing as smooth a curve as possible through those points. I highly recommend you doing that in pencil, so if you do make a mistake you can rub it out and then it's clear to the examiner which is your correct answer line. Question 21. Jing has £2,450. She saves some and then gives the rest to her 4 brothers. Money saved to the money given to the brothers is in the ratio of 2 to 5. So we've got money saved and then money given in the ratio of 2 to 5. She gives each of her 4 brothers the same amount. Does each brother receive more than £430? You must show your working out. So the first thing we're going to do is we're going to share the total that Jing has into this ratio so we can find out how much was saved and how much in total was given to the brothers. So 2 parts plus 5 parts is 7 parts. So we're going to do 2,450 divided by 7, which is 350. 350 times 2 tells us that she saved 700. And then 350 times 5 says that she gives the brothers £1,750. Okay, so they're each going to receive the same amount and there's 4 of them. So if this is the amount shared between the brothers, we're going to do 1,750 divided by 4. Divide by 4. Which is £437 and 50 pence. Did they receive more than 430? Yes, they did. Make your yes nice and clear and show your working. Question 22. The pie chart shows information about people at a fair during 3 days. So we've got a pie chart for Thursday, Friday and Saturday. We know the angle for the Friday part of the pie chart. We know the angle for the Thursday part of the pie chart. There were 132 more people on Friday than Thursday. Work out the number of people on Saturday. So the first thing we're going to need the angle of the people, of the proportion of the pie chart for Saturday. So this is a full circle, so they're going to sum to 360 degrees. So we're going to do 360 subtract 80, subtract 25, the 2 angles that we know. That's 255 degrees. So Saturday is 255 degrees. There were 132 more people on Friday than Thursday. So now we're going to compare these 2 values. So the difference in angles between Friday and Thursday is 55 degrees. So there was 132 people are worth 55 degrees in that pie chart. So now we're going to find out how much 1 degree is worth. So to go from 55 to 1, we're going to divide by 55. So if we divide this side by 55, 132 divided by 55 equals 2.4. So 1 degree is worth 2.4 people. We worked out that Saturday was worth 255 degrees. So if we're wanting 255 degrees, we're going to multiply by 255. If we do that on this side, 2.4 multiplied by 255 tells us that Saturday was 612 people. Again, I've just used a proportion table to keep all my working out organised and so I don't get confused with it being all over the place. Question 23. Use trigonometry to work out the value of x. So x is this length here. And if we're using trigonometry, the first thing I'm going to do is label the sides. So here's my right angle. The side opposite the right angle is my hypotenuse. This is the other angle that I've been given. So the side opposite that would be the opposite angle. And then the remaining opposite side, and then the remaining side would be the adjacent side. So now I need to figure out which of the trigonometric ratios I'm going to use. So I'm looking for this, which is the opposite, and I've been given this side, which is the adjacent. So I'm dealing with the opposite and the adjacent. However, you've been told to remember this. So we have SOHCAHTOA. Okay, SOHCAHTOA, to remember the trigonometric ratios. Adjacent and opposite. Well, the only one that has the adjacent and opposite in is this one. So we'll get rid of those two so we don't get confused. T is for tan. So we're using the tan ratio, and it will be tan with the angle that we've been given. So tan 58 is equal to the opposite divided by the adjacent. And now I'm going to substitute in what I know about the opposite and the adjacent. So tan 58 equals, the opposite is x and the adjacent is 46. Now, what I'm going to do here is I'm going to use this formula triangle like we use a speed, distance, time triangle. So I'm trying to find the opposite. So if I cover up the opposite in that triangle, I'm doing tan multiplied by the adjacent. So I'm doing tan x is equal to tan 58 multiplied by 46. So I'm going to pop that in my calculator. Tan 58, make sure you close the bracket, multiplied by 46. That tells me that x equals 73.615388834. Now, it hasn't told me to round it to any particular value, so I can just write all of that on the answer line. And I would probably do that just in case I decide to round it wrong. It hasn't asked me to, so I'm just going to write the whole thing on the answer line. Question 24. Millie is estimating the value of this calculation. She rounds each decimal number to one significant figure. Part A, work out Millie's estimate. You must show your working. So the first thing we're going to do is any decimal values in this calculation, we're going to round to one significant figure. So 8.34 would be 8 and 10.21 would be 10. Now we have them rounded to one significant figure, we're going to substitute them into this calculation. So we have 1 over, in brackets, the cube root of 8.34 we've rounded to 8, and then that's all squared, and then we're multiplying it by 10.21, but we've rounded that to 10. And then we're going to stick that calculation in our calculator. So 1 over bracket cube root of 8 bracket squared multiplied by 10. So it's important that what you enter into the calculator looks like what you've written here with the brackets and everything. So the squared is outside the brackets for the cube root of 8. The multiplied by 10 is away from the squared. It's not part of the power. So it's making sure it looks exactly the same. And then press equals. Okay, so we get 1 over 40. So it doesn't say whether to give your answer as a decimal or a fraction, but to be safe, I've got 1 over 40 there. I'm now going to convert it to a decimal, and then which equals 0.025, and I'll probably put 0.025 on the answer line there, purely because we were dealing with decimals in the calculation. That's the only reason. But you would be okay with 1 over 40 as well, I'm sure, on the mark scheme. Okay, 24b. Millie says, my estimate must be more than the exact value. Without working out the exact value, give a reason how she can know this. Okay, so because 8.34 was rounded down to 8 and 10.21 was rounded down to 10, we're dividing by a bigger number. So they were rounded down, so if we were using the exact values, we would be dividing by a bigger number, which would then make our answer smaller. So we're going to write that down. So both numbers were rounded down if we used the exact values we would have divided by a bigger number and gotten a smaller answer. Because the bigger the number you divide by, the smaller your answer is going to be. Question 25a. Factorise x squared, add 8x, add 15. So what I'm going to do to factorise this expression is a quadratic. I've got a quadratic term and I've got the number on the end, so I'm definitely going to need two brackets. And I want two numbers that multiply to make 15 and then add to make positive 8. So numbers that multiply to make 15. 1 times 15 and 3 times 5. That's the only options I have. Now I want them to multiply to make positive 15 but add to 8. So 1 plus 15 is 16. That's not going to work. 3 plus 5 is 8. So I'm going to use positive 3 and positive 5, and then I need an x in both brackets. And then I'm going to write those on my answer line. Part B, write down the two solutions of y add 2 multiplied by y subtract 4 equals 0. So the solutions are the opposite to what's inside the bracket. So the first solution for y would be negative 2, opposite of positive 2. And the second solution for y would be positive 4, which is opposite to negative 4.